Hello, my name is Robbert Jongeling. I am a PhD student at Mälardalen University in Sweden. Thank you for tuning into this presentation or watching it at some other time than the OpenMBE workshop models. I will keep this recording short since also our workshop paper is a short paper on a proposal for boosting OpenMBE with model code consistency. I'm working on a project in which we try to establish some structural consistency between a system model and code. And then one of our ideas was to utilize the OpenMBE framework. And this short paper is meant mostly to discuss the idea with the community. And in particular, do you think that this is a reasonable extension to the existing framework? At a very high level, our idea consists of three ingredients. First is generating documentation with cross-references between the model and the documentation. And then the second ingredient is to allow new cross-references between the code and the documentation to be created, thereby creating a kind of bridge between model and code through the documentation. And then the third ingredient is to analyze the consistency between model and code using these newly established links. In the next slide, I will introduce a running example that illustrates the idea. And the remainder of the presentation then consists of some motivation describing the industrial MBSE setting in which we would like to establish these consistency checks and why we would like to do that. And then I will detail each of the three ingredients and finally discuss some of the limitations that we can encounter with this proposal. So let's look at a running example. I'm showing here a sketch of a state machine diagram for an automated door, just to illustrate the idea. Of course, in the end, this is supposed to be an entire system model consisting of many diagrams. The bottom left of the figure illustrates documentation that could have been generated from this model. So here it's a very small sample that just represents this state machine. And we can see that there is a cross-reference between the concept door in the documentation and the state machine representing the door. The bottom right of the figure illustrates the code that is implemented. And there we imagine again a cross-reference, but now between the abstract syntax tree node of door, the class door, to the documentation. And then on the far right, a consistency checking analysis script is illustrated, which is envisioned to detect structural inconsistencies. So before explaining each of the ingredients a bit more, just a brief introduction to the setting in which we envision this to work. So roughly the setting that we encounter is like this. The main flow of MBSE activities is that a system model is created or new functionality is added to an already existing model. And then documentation is generated from that or kind of regenerated if there was already an existing model. And in addition, once in a while, when there are enough changes piled up, then the system engineers present those changes in handover meetings to software engineers who then implement the design. So the model contains roughly of a decomposition of the system into different function blocks, and further it details if those functions should be implemented in hardware or in software. And then for the software blocks, several diagrams are included to design the structure and the behavior of those blocks. So in this setting, the consistency between the model and code is of interest because of the usual reasons. Of course, you want the code to be synchronized with the design, but also the model should be an accurate documentation of the implementation, since there might be maintenance activities far in the future. And also there might be reuse of parts of the model in new products. So to establish this consistency, there is a need to somehow have some traceability between the model and the code to know what parts of the model are implemented in what parts of the code. And furthermore, while development is now done based on generated documentation from the model, sometimes during implementation, changes are made for things that are kind of mistakes currently in the system model. But at this point, there is no backpropagation of those changes to the model. So then the model and code can get out of sync. So for these reasons, we want to establish some kind of automated consistency checking methods in this scenario. And we look at OpenMBEE for hosting those consistency checks in a way. So let's look at the different ingredients more closely. The first ingredient is to automatically include the cross-references between model and documentation during the generation of the documentation. So currently in the setting, the documentation is generated from the model using templates filled in, which are filled in with details from the model. So in that setup, we can try to include the cross references between concepts already while generating the documentation. In the running example, it would be the concept of door mapping to the state machine door. So documentation and the model are currently kind of in sync by construction, and we will keep it like that. But in addition, we will add those cross references, which is very close to what is already supported in View Editor now, which is the creation of cross references between concepts in the documentation and in the model. Then the second ingredient is the creation of cross references between the code and the documentation. So since in this setting that we are working in, the code is already based on the documentation. So given the generated documentation, people are implementing the system. And then during this activity, we envision that as an additional action, there can be cross-references created between abstract syntax tree nodes from the code to concepts in the documentation. So in this example, the class door would be mapped to the concept door in the documentation. And so the idea is that there would be some kind of plugin for the IDE, which would provide view editor-like functionalities for establishing these cross-references. Then the third ingredient is intended to take the high-level information that we gathered in the previous step and then provide automated consistency checking for the structural consistency between the model and the code via the documentation. So since we know that the class door is linked to the documentation concept door, and that is again linked to the state machine door, we can then check the consistency between the state machine and the class. And in this example, we would find that in the code, the door provides open and close as functions, but actually in the state machine, there is also a concept blocked, which is missing in the code. Furthermore, you would see that in the code, there is a divergence from the model, since there's an additional function force close, which is not present in the state machine. So there are some obvious limitations to this proposal. The first is that, of course, we focus only on structural consistency. And the other is that creating these cross-references manually between the code and the documentation might not be so obvious and might be too cumbersome in practice, but we will have to find out about that. So to conclude, I repeat the abstract feature from the beginning, showing the idea of linking the model and the code via the generated documentation. So since we know the model to generated documentation, that those are in sync, and from those we know we can generate the cross references. And then while implementing, we can ask the engineers to create the cross references to the documentation. Thereby we can obtain a path from the model to the code. And then the question is again, can we boost OpenMBEE with model code consistency? Is this a reasonable idea or a reasonable approach according to you? So I'm very interested to hear the thoughts of the people who have developed the framework and who have worked with it, to see if this is worth developing further or investigating further. Thank you for listening. If you're watching this video and have some questions, ideas, or suggestions, please do send me an email at this email address. Thank you very much.